Okay, and the governor, okay. So that's our second presentation. It is called Connecting Galaxies. And this is presentation not about databases for a change. It's like literally not about databases. It's about applications. So one of the galaxy is definitely the application galaxy. And for this occasion, here is Alisa, who is alien from this foreign galaxy. She is an application developer from Raven Holdings, and if it's not Alisa, none of this would happen. So she will start this presentation and tell us all about what application thinks about database.
Sure. So we're going to talk about why galaxies. This is working. All right. So don't need two mics. So we want to talk about why galaxies. So we're not talking about aerospace or anything. As Henrietta said, we have the application and the database. And these two galaxies, in order to make any kind of application that is going to be live and on the web or anywhere else, you kind of need these two systems to talk to each other, typically. That communication is vitally important for most of our applications in the world today. So both of these systems are vast and complicated. They're separated by being built in two completely different languages, two different subjects, and like two different, like just how they work is very different. But we need to be able to talk to each other. So separately, we've all developed, the database developed like a Star Trek communicator, and in order to talk to itself, and the applications developed the Star Wars Comlink, and now we need these two separate communication devices to be able to transfer their information. So we've developed some jury-rig protocols in order to get these two to talk to each other, but they're not usually very optimized, and you can definitely run into performance issues with these systems. So why do we care about these kind of galaxies? The database is really good at doing what it does. It's very good at optimizing its individual queries. We've seen explain plans. People are always working to make these things better and to improve performance within the database. We're not great at getting this performance between our two galaxies working because the application doesn't know about explain plans, and the application doesn't care how the database executes its query. It just wants the result of this data set or this query that it's going to use. So the application is going to use object-oriented design in order to implement its performance. So a long time ago, applications decided this is how we were going to design things. Java, C#, etc. Just everyone's using object-oriented design nowadays, and that's kind of how things are built for web applications. We have the JDBC connection in order to communicate to whatever database you are connecting up to, whether it's Express or anything else. But that's the only visible part of the connection. And so then you just say, okay, well, the JDBC is not great at handling these complex queries and these complex structures, so we have to just we have to just live with that. But what would be really nice is if we have this dream of, I have a complex object like a car, and I want to store that car somewhere, like in a garage. I would prefer to just hand a key over to someone in order for that car to be stored. So that way, I don't have to do anything special with the car. Database doesn't have to do anything special with the car. We just are able to store this car. So some people actually liked this idea and tried to introduce it to the database side. So introducing object-oriented design to the database. These logos probably aren't familiar with because none of these object-oriented databases really took off. Nobody really knew how to implement it. Nobody really was able to do this in a robust way that was scalable and everything like that. But we'd still really like that idea. Instead of that beautiful dream, what we're left with is the ORM system we heard briefly about earlier today, the Object Relational Mapper. Basically what this is doing is the application takes its complex object, defines how every piece, every individual scalar part is mapped to a database table. And so every single piece of this complex object gets transferred one by one to the database, one at a time. So that means if you have a very complex object, you might be doing and end up with many database queries for a single select or for a single read or write. So every single piece has to get transferred separately, which is not what we particularly like to see happen. In our example, that means we'd be disassembling our car in order to move it into the garage, taking the wheels off, taking the brakes off, taking your screwdriver and your mechanical tools and just piece by piece giving that over to the garage owner to store in the garage. That's not very good. Is anyone happy? No, we're not happy with that solution. But do we have a better one? Because those object-oriented databases didn't work out. But what we have developed is JSON. Both the application and the database, Postgres, can use JSON and read JSON. So what we do is instead of transferring our complex object via the ORM, we transfer it via JSON. The application has standard serialization, deserialization tools to map our complex object to a JSON structure. It then can send that JSON structure as text to the JDBC, which can, a single transfer, to transfer all of that text over. The JSON then gets picked up by the database, and then the database and Postgres has tools to map that JSON structure to its relational models. This means communication is no longer a roadblock. Our complex object was delivered to the database with one query. On the application side, we get to use standard serialization, deserialization tools. This is the same that we would get with any kind of web request on our side. On the database side, we get to use query language, and we get to use the explain plans, and we can optimize all of our calls so that every single piece is functioning as great as we can get it. The JDBC connection we still are using, as you saw, but it's only used as a JSON transfer for one object. And thus our dream comes true. We are able to drive the car out of the garage and take with it all the pieces that we need for it to function. The driver gets, if we want the case for different applications, the single database query can return pieces of the car earmarked for the driver, like the seat and the steering wheel and mirrors and the gas pedal. Whereas the engineer can have the earmarked pieces for the engine in order to monitor performance and how the car is running and all of the vibration of it, etc. So this is what we want to happen. But like this is a very theoretical discussion. So let's actually, I'm going to hand it over to Hetty to actually talk about the implementation of it.
Let's see, but I think this should be double check. Yes. Doesn't.
I didn't see it working.
Okay. Okay. What I'm going to do now? No,
You can. I can do here.
No.
Or you can.
All right. No. It's fine. You'll need to show the code anyway. All right. So that's typical example. So that is application topic. So application thinks it's all about JSON. So let me make it straight. It's not about JSON. It's about functions, right? Because what we, as database people, what we want. So we want to have fun communication between application and the database for the whole endpoint. So whatever application needs, all data to display, it should be retrieved from the database in one shot. You know the deal, right? And again, what's the best way to do this? Yes, to use a function because we can hide everything, all our perfection and imperfections, all our optimized and not so optimized query. We can wrap it in a function, and then the only thing application have to do would be to execute the function. All right, it's working. Oh, cool. Okay, okay. So we have function, and what? Wait, which was? Okay. Okay, yeah, okay. So we create a function. So in order to create this function, we have the user-defined type, and our functions will return this record type, so presumably everything what application needs. And then we can define many functions which would search whatever, for whatever criteria and return exactly the same type, and then we kind of have the strong type, and we can make sure that each time our object looks the same. This is actually pretty good because application only has this like outside, so we return the object and all the details are hidden. It's all good except of whoever tried it with me, and I kind of have a feeling that if not half, that 1/3 of this audience did something like this with me at some point of time. So what happens next? Again, what happens is complex objects are nested. So we do not really have user account, first, last name, and that's it. We have all these complex structures. So in the user account, we have address object, we have phone object, we might have multiple phones, we might have multiple emails. So the object structure becomes complex. And here, where is the fun part starts. Because if you ever try to do it in Postgres, you know that Postgres makes it look like it retains the type of the embedded type, but actually it does not. So if you try to define this record as the user-defined type with several embedded record types, it theoretically knows in PG class that's what's going on. But if you try to select, what it will select what you have like on the bottom of the slide. So the substructure will be returned like one element. And you cannot tell which of these are dates, which are numbers, which are text, so that's it. So most of the time, this will be my end of story of my journey with application developers, because they said, let's do it the old way. So fortunately, it was not a situation at Paravan Holdings, and here application developers said, let's try, let's see what we can do. And we tried. So that was second step. Hey, can you return this embedded object as JSON? Well, actually, yes, I can, because Postgres has this JSON support. So actually, instead of trying to put this embedded record type, instead I have JSON in place of this embedded record. And then this looks beautifully, and we preserve the structure and return whatever we need. So after first success, no, these application developers are so demanding. So next thing you know, what they said, hey, can you just return the whole thing as JSON? I'm like, okay, actually, I think I can. And how far we can go? We ended up actually having all the functions which were used by application to return JSON objects. So these folks were overjoyed. Until once we decided to search, fortunately it was not in production, okay? Fortunately it was on the low-level environment. But we migrated quite a bit of that, and we wanted to search for the guy named John Smith, all user accounts, and going. So why it was going? Because there are several problems with this approach. One, that building this nested JSON is super time consuming, because if you want to build the JSON properly this way, you actually need to execute embedded queries separately for your JSON. So if we have like 1,500 John Smiths in the database, it would be building this JSON, all these embedded selects like 1,500 times, and that does not look pretty. Okay? And that's one thing which definitely we didn't like. The other thing which they do not care, but I care because I'm all for strong type. So I'm losing this type dependency. So actually we had to develop a very, not complex, but some special ways to ensure that JSONs which are returned for the same object are actually structured the same, and we did not miss any JSON element anywhere, which was not so ideal, though it was good. So it had been like this for a while until I was given the gift of the JSON aggregate function. And that's okay. So you'll tell me why you had to invent JSON aggregate. There is JSON aggregate. So if you look at this code, it's a little bit different than regular JSON aggregate, what we have. So what this function allowed us to do, it allowed us to It allowed us to build JSON as an aggregate within the function. If we have, for example, the user account, and we have additional several phones, several addresses, several everything, so then we actually can build it as a normal aggregate function. So we can group by all the user account elements and then have all these nice like JSON arrays for each of the embedded JSON types. So you aggregate function, and then you build aggregate, and this actually works very cool. And then at the end, what we do, because you know what, it's very interesting, but JDBC actually does not know about JSON. So you actually, after you've done all of this, you need to wrap it to the text array, and then you can pass this text array to the application, and that application knows that this text array is actually an array of JSONs, and then they do what you just said, so they actually deserialize it and build their object. So what actually happened, that is literally we use JDBC as the transport layer, and we keep the similar object structure on both sides of it. So now we can return to types, because otherwise, I do not know, I'm returning JSON. JSON doesn't have type, JSON is JSON. So what we have now, we actually flashback, we built complex type the way we want. So we have record type phone, record type address, record type email. Then we have arrays of them, and we build all this user account record with all embedded arrays. But then, when we build this object, we build it using this JSON aggregate functions, and I think that we want to show the code, right?
Sure.
Okay, so now, okay, so that is actually, that will be like very fast scanning of our real code base. So, like, okay, be with us, okay? We do not plan to reveal all the details, but we want to show the complexity, the real complexity. Because it's all like looks fun, but it's, yeah. So that's basically how it looks like. So we build the types, we build the types, we build the types, we build that, we build all these like embedded types, and at the end we build the user account, and then actually we have also the person record, which accumulates. So we have here two levels of embedded types. So then we have separate functions to build the search criteria, because again, you know about Postgres, right? You cannot really parameterize, I mean, you can parameterize queries, but it works much better if you actually build the query dynamically, and then your selects actually are executed in a very optimal way. So then, at the very end, that's how we build the result set. So we aggregate as many levels as we need. We use this JSON aggregate function, and at the end, so we return this humongous JSON, which is still built based on like, so we execute normal SQL statements without any embedded stuff, right? Then we use this JSON aggregate functions to build a properly aggregated JSON record. And then at the very end, we actually take this JSON, and then we return the result as the array of text. So that's basically, yeah, that's basically how it works. And what we have, yeah, that's what happened. So what we achieve this way, that's how our function works. So once again, what's the magic here? So the magic is that we have no ORM, we have zero overhead. So on one hand, we achieve that on the database side, but I told you it's not about database, right? It's about application. So on the database side, we can do what we really want. It's important, and we know how to do well. Because we can, like, for example, based on different search parameters, we can build query dynamically, we can build it in a super optimal way. And on the application side, we give the application exactly what they want, exactly what they need in format which is preferable. So now we said we are not naming evil. Anybody sees any room for MongoDB? Nope. Okay. We do not see them. Yep. So yeah, and that concludes our presentation. And any questions? Yep. Okay. Is it good or bad? Yeah, uh-huh.
So I'm not very good at my reflection on that. So I really enjoyed that presentation. The age-old object relational mapping problem. And I have to work in object design. One of your slides went back to that. I thought was a very interesting approach using JSON in this way. And one of the authors of the JSON technology, Postgres is here. So this
Yes.
is a very good vision from the application side of the object relational problem. Agree with everything you said.
Thank you. Thank you.
Is there anything you haven't been able to express in any sort of object graphs you have not been able to express using JSON? Any sort of complicated things or?
Not yet.
Not yet. There were some slides that we took out of the presentation for time's sake that kind of led up to the solution we have today, and we presented here, that all the issues that we found, we've been able to overcome. And
What about the very large result sets or things like that?
Say that.
large results. That's so like your
Oh, yes,
Johnson
like
query.
result sets, we were actually, okay, so again, we kind of like rushed through them because of the limited time at this conference, but yes, not, look, I've been, I've been very sensitive to, like, you know, keeping the schedule moving as it is. Actually, if you look at the real details of this user account creation, so you can see there are several different nested objects on the same level, and you could see, probably we like scroll through this, that we have the separate function to build this CT. So again, we build separate version of aggregate where we select everything plus one detail, unit all everything plus other detail, and everything plus other detail, and all the others are null, and then the aggregate. It looks like a charm, you know. It's actually unbelievable. It looks ugly because I feel embarrassed when I need to, okay, you know, but when I build the sequel, it's like 200 lines of code, but it works. It works. So if you ask, like, you know, whether we made technology very scarce, okay, somebody promised me. Okay, didn't promise, expressed interest, okay. Yeah.
It seems to me that one of the big problems with RX in general is that you often sling around far more data than you actually need for any particular query or use case. And it would seem that this would have that same downside, right?
So one of the things that we're not actively using a ton of, but we did develop specifications of being able to, because this is all functionalized queries, one of the tools we developed earlier on in the process was being able to pass in JSON parameter names to say, I want to, so for our user account example, I only want to include address and bank information to this user account result set. So don't give me phones, don't give me anything else. So like we were able to, by adding additional parameters, choose which parts of this result set we wanted to transfer.
But actually, you know, when we figured out how to build them properly, this became not a problem. So that's why we kind of abandoned this, because we didn't need to do it for performance reasons. Actually, the real problem of ORM mostly is that there's like a big number of, like, large number of tiny database calls, so big number of round trips. That's the core problem of ORM. So here we solve this major problem because we deliver everything, literally everything with one execution, and whatever, even if it's like multiple SQL, so in this case it's one, but everything is executed on the server, and then we just wrap our result set the way how application can consume it, and then we ship it. Actually, in order the excess data to be a problem, it have to be like very excessive data, which is unlikely for the OLTP application. So that is definitely like OLTP solution based on like small transactions. Oh,
When you talk, just to follow up on that, when you talk about parameterizing it for returning specific parts of that, I mean, I guess that kind of feels like, it sounds like you're kind of reinventing GraphQL at that point.
No, Yes?
Hetty, how easy is it for non-SQL experts to make changes to the app in this?
They do not need to know anything about actually for that.
Okay, so
Okay,
what if you need to add-
I just should speak here for this.
So do you mean more like modifying the SQL queries or adding stuff to the?
Yeah, say you want to add some more tables or, well, not tables, but more objects. How easily can you do that?
I've done it before. I have some experience with Postgres though, or SQL in general. So I wouldn't consider myself an expert, and I haven't had too much trouble doing that.
So it sounds like you're a Java shop.
Yeah.
Okay, so can the average Java dev go in and create objects here without having to involve the
I think,
DB?
so my guess would be that there would be some DB set up for figuring, I don't know that the average Java developer would have a ton of experience with functions, which is what we're mostly using, and I don't know that they would necessarily, without an example, be able to build this up, but like I feel if they had a couple examples, I don't see any reason why they shouldn't be able to pick it up.
Okay, Dave, I told in my presentation number one, the biggest, mistake my company made is hire me as a first technical person. So all the rest is a consequence, okay? So because I started building this, and database developers are like the most, not the most, but very valuable, okay, part of the tech team, and actually we have a relatively high ratio of database developers versus application developers, and that's just how we operate. That's our choice. That's how we operate, and we actually, again, knowing where your question comes from, we have very clear separation of business logic and database logic, and most of these functions that is the way that application can actually change the application logic, the business rules, without changing the functions, only changing the parameters. Like for example, when we need to send the note to the customer, which transferred from status 1 to status 7, after 7 days of inactivity, all this 1, 7, and 7, they are parameters. So this business rule when we send notes can change, and it will be different for different products.
You're gonna have to
Yeah.
finish at the cocktail hour. I'm sorry.
Sorry.
I'm gonna preempt the question, but thank you very much. This was a great presentation.